minutes to explain a thesis can seem like a ticking time bomb to most graduate students. But as an Arctic researcher, I study changing northern landscapes. I'm reminded of this urgency every day. You see, northern soils store a huge amount of carbon, approximately half of the global stock. This carbon has been stored in ground that is permanently frozen, called permafrost. But as climate change warms temperatures, it causes permafrost to thaw, which can release some of this ancient carbon to decomposition. When this carbon decomposes, it releases greenhouse gases, such as carbon dioxide or methane. These contribute to climate change and cause more permafrost to thaw. The large amount of carbon stored means that it also has potential to release large amounts of greenhouse gases. This could severely affect not only the Arctic, but the entire planet. However, only a small portion of what is stored may actually be released, depending on how quickly this carbon is decomposed. Decomposition is completed by very tiny organisms, such as bacteria, that break down carbon when they consume it for energy. These microbes can be picky eaters and prefer some forms of carbon over others. Carbon is stored in many forms that can be small and simple or large and complex. This is sort of like the difference between milk chocolate and dark chocolate. They're both still chocolate, but just as you may prefer milk chocolate from Switzerland, microbes also have preferences for the forms of carbon they will decompose. The forms of carbon are not well known in Northwestern Canada, especially in different landscapes and by depth. But these areas may decompose at different rates. So in order to predict how much carbon may actually be released, we first need to classify the forms of carbon in these understudied areas. For my research, I will use permafrost cores that are long tubes of soil that span up to 20 meters, taken from multiple landscapes across Northwestern Canada. This represents one of the most diverse permafrost sampling in this area to date. I will use soil from these cores to classify the forms of carbon in these different landscapes and by depth, and precisely measure the rate of decomposition completed by microbes. The Arctic is warming at twice the rate compared to the rest of the world, and permafrost thaw may release large amounts of this stored carbon. My research will be among the first to link permafrost thaw with decomposition rate in Northwestern Canada that will allow us to better predict carbon release from diverse landscapes and how it may impact the rest of the world. I know I've taken up 3 minutes of your time, but I hope you're willing to spend more than a few minutes to consider the fate of the Arctic. Thank you.